A particle travels along a curved path described by the function vector. So you have the function vector here. R of t equals 4 cos t I plus 4 sin t j plus 3t k. You must find its velocity at any time t, t seconds. You must also calculate the speed of the particle at t equals 0 and the acceleration at t equals 0 seconds. Okay. Now, let's write this down. You have R of t equal 4 cos t. So let me rewrite that. 4 cos t I plus 4 sin t j plus 3t k. Now, that is the curved path, right? It is showing really a distance. Now, the thing is, you want the velocity. The velocity is the rate of change of distance with time. So how do you find the velocity? And by the way, whether I remember or not, let me remind you now. You must pause the video, write down the question and solve it before you watch the remaining part of the video of me giving my solutions. Okay, so you've done that. You've paused the video and you solved it. What did you get for your answers? And remember, the marks go for the steps. The steps are the more important things, not the answers, alright? So ensure you understand how to do it. So here now, you are going to find the rate of which distance change with time. So you're going to find, well, in this case it's not partial derivative, it's full derivative because there's just r and t. So it's dr by dt. If there was some other variable, you'd have to say delta r by delta t because that would be partial differentiation. This is total differentiation. So when you differentiate this with respect to t, you differentiate cos, you get negative sine. So you have negative 4 sine t in the I direction, right? Now plus, when you differentiate sine, you get cos. So the derivative of sine t is cos t. So it's 4 cos t, the j direction, plus, now differentiate this with respect to t, you get 3 in the k direction. So you have a magnitude and you have the directions given by I, j, and k. So that's a velocity. Alright? Now, here, that's part 1. The velocity at any time t seconds is this. Part 2 now. The speed of the article at t equals 0. You change the word from velocity to speed because you will not have a direction now. Now at t equals 0, dr by dt is negative 4 sine 0, right, plus 4 cos 0 plus 3. Sine of 0 is 0, so this becomes 4 plus cos of 0 is 1, so 4, 1, 4 plus 3. Okay, and so you get 3t at t equals 0 So just to make sure of everything, you have negative 4 sine ti plus 4 cos tj plus 3k, and at t equals 0, you're going to get 4 that 0 plus 4 times cos 0 is 0 plus that plus 3. Alright, so here this is going to be 7. So you have 7 the speed in meters per second. 7 meters per second. Now the acceleration at time t equals 0. Now you have to remember, from physics class or so, what is meant by acceleration, right? Remember, acceleration is a change of velocity with time. So while velocity is a change of distance with time, I'm use big D for distance. Now acceleration is going to be the change of velocity with time, the dv by dt. But what's the change of velocity? The change of velocity with time. The change of distance with time. I mean, change of velocity is going to be the change of distance with time. So the change of with time of the change of what? Is going to be the change of distance with time, dt. So what you have is d squared of the distance by dt squared. So you're going to find the second derivative, right? So it's going to be the second derivative. So you differentiate this again. So d squared r by dt squared equal, what do you differentiate this? Sine, you get cos, so it's negative 4 cos t, plus when you differentiate cos, you get negative sine, plus negative 4 sine t. Well, this would be 0 plus 0 because it's just 3. Right? Oh, the ij and k. I, j, and 0, k. Alright, at t equals 0, what happened? This is t. Cos of 0 is 1, so it's negative 4 times 1. Right? In the I direction. What happened here now? Sine of 0, this is t. It kind of look like a, but I wrote it bad, it's t. So that's sine t j, but when t is 0, sine of 0 is 0, so this is becomes 0 plus 0 plus 0. So it's negative 4 in the I direction meters per second squared. Alright? So negative 4 meters per second squared. Okay, so that's that for now. I'll see you in the next video.